Okay, so I wanted to tell you a little bit about some experiments I did implementing this stuff, so that to give a feeling of these three different approaches we have, right? So what are the three approaches? We have implicit memoization, explicit memoization, and dynamic programming, right? And we kind of know that their performance is going to be ordered more or less in this relation. So the problem I used for my experiment is edit distance, which is a problem we will see in the next lecture. It's a very cute dynamic programming problem that is in fact really useful, unlike longest increasing subsequent, which is also useful but less commonly used. And I just wrote the code with all the three versions. I wrote it in C++, I assume, because that's the language I always use. And what I generated random strings of that length to generate, and I computed the edit distance. Edit distance takes quadratic time. And I had a dynamic program, which this is the running time in seconds. So you can see the dynamic program is very fast. Then we had the partial, which is partial means that I did, explicit memoization. And then we had the implicit memoization. So as you can see, the running times are as we expect them. Right? The implicit memoization is slower than the partial, and the DP is the fastest. And you can see when the problem is really large, in fact, the implicit memoization ran out of memory, sorry, which, is kind of sad, but okay. And that's it, right? So the thing to remember here is that this is a very special case. This is edit distance is a very simple dynamic program. So the overhead of doing the implicit memoization is quite large. So the running time difference is quite significant. But in practice, the running time would not be so... First, you might not care about the running time that much. So this difference in practice might be just not important. The second thing is that real-world problem tends to be much more complicated than edit distance. And I would expect the gap between the dynamic program and the implicit memoization for complicated dynamic programming problems. I expect this gap to be much smaller. Right? This is just a very special case. Anyway, it does show that asymptotically it doesn't matter. If you do implicit memoization dynamic program, you get different running times, but the difference is only small constant, and you might just not care in practice. Right, so that's all I have to say. Okay, what about, what should you use in practice? Well, it depends on how much time you have to implement your algorithm, right? So this is one of the things we are never mentioning in this course, which is when you work in programming, it's really important, which is how complicated is the algorithm and how long it would take you to implement it. In many cases, you don't care about running time if it takes you a month to program. If you can program something in 10 minutes, and there's something you program in 1 minute might be horrendously slower, but for the size of problems you are trying to solve in practice, it doesn't matter, right? So programming time is in fact an important consideration in practice. So it really depends which programming language you use and what and how well it supports implicit memoization and so on. But in job interview, people would probably expect you to do dynamic program, unless you explicitly tell them that, do you want me to do this or this? So you need to know that. And if you're going to do production code that's supposed to handle huge inputs, then you definitely want to spend the extra effort and write the dynamic program, because it's definitely faster. And that's it.